9.5 continued. Hazardous weather and geographic regions at risk. Still continuing tornadoes. Previously, we discussed the organizational and mature stages of tornadoes. The third tornado development stage is the shrinking stage. The supply of warm air is reduced and tornado begins to thin. It is more dangerous because wind speeds increase relative to the ground as diameter decreases. And finally, the last stage, the rope stage, when downdrafts cause the tornado to move erratically and disappear. Phew! Bye-bye, tornado. Tornado classification is according to damage that they produce using the Enhanced Fujita Scale, EF. This table shows the scale of tornado intensity and can be found in your book and online. I will just cover a bit of it, but I encourage you to carefully read the whole table on your own. Okay, an EF0, the least scary tornado, winds 65 to 85 miles per hour. Light damage to homes and trees, signs damaged, and probably mobile homes decimated. They always are. Compare that with an EF5, winds more than 200 miles per hour. Incredible damage. Well-built buildings are leveled, moved off foundations, and swept away. Car-sized missiles fly through the air more than 100 meters. Trees debarked, possibly dogs too. Incredible phenomena will occur. I think this is when the grass gets blown into wood and that type of strangeness. I know that the wind makes quite a bit of noise at my house when my anemometer records wind at about 25 miles per hour. I can't even imagine what 200 miles per hour winds sound like. Remember, the EF scale relies on damage after the tornado has passed, similar to the modified Mercalli scale for earthquakes. This is perception of damage after the event. I have never personally seen a tornado or the damage it has caused, but I have seen these cute little tornadoes over the ocean called water spouts. They develop beneath fair weather cumulus clouds as a result of wind shear. Not so dangerous. The three pictures below are all of water spouts. Tornado occurrence is primarily in United States and Canada in the Plain States. Severe tornadoes also occur in Bangladesh. Tornadoes primarily occur in the late afternoon or evening in the spring and summer because that's when we get the strong difference in temperature with altitude, with the air near the earth being warmed all day. Water spouts primarily occur in tropical and subtropical areas, especially the Gulf Coast, Caribbean Sea, Bay of Bengal, and South Atlantic. Here is a map of the United States that shows average annual tornado incidents per 26,000 square kilometers. The red areas have more than 9 tornadoes per year, while the blue areas have 0.5 to 0.9 tornadoes per year. And you may ask, how can there be half a tornado in a year? And the answer is, you don't. You have 1 tornado in 2 years. Then average it out. Okay. Not the location of Tornado Alley. Note the location of Tornado Alley. It stretches from Texas through to South Dakota. This is where most of the tornadoes occur, but there are also quite a few through the deep south to Florida and over towards the southern Great Lakes area. Once we get over to the Appalachians and Blue Ridge Mountains, not as many tornadoes. And looking west, once we hit the Rockies, the incidence of tornadoes goes way down. That doesn't mean we don't get any tornadoes over here in Idaho. We just don't get them very often. And even when we do, they tend to be lower on the Enhanced Fujita scale. Blizzards are another type of hazardous weather. They are severe winter storms with large amounts of falling or blowing snow, high winds, and low visibilities for extended periods of time. which is often called whiteout, which is extremely low visibility, just with white whirling snow. In the United States, a blizzard is defined as winds greater than 56 kilometers per hour, which is 35 miles per hour, and visibilities are less than 0.4 kilometers or 0.25 miles for at least 3 hours. In Canada, the definition of a blizzard is slightly different, with winds greater than 40 kilometers per hour or 25 miles per hour, with visibilities less than 1 kilometer or 1.6 miles for at least 4 hours. No need to memorize these different definitions. Just be aware that the technical definitions differ, so that a storm in one country may count as a blizzard, but then cross a political line and not technically be a blizzard anymore. Image is a picture of a blizzard. Here are a couple terms associated with blizzard conditions. There are ground blizzards, where winds blow previously fallen snow, so it looks like a blizzard, but there's no new precipitation. Also, wind chill is a measurement of wind that cools things like skin, evaporating moisture, reducing the time it takes for frostbite to form. The image depicts a natural service function of blizzards, using snow to chill various beverages right outside your door. Blizzards form in the interaction between an upper level low pressure trough and surface low pressure. Generally, they occur in eastern Colorado, central Alberta, east coast, and northern Gulf of Mexico. The Colorado and coastal storms are primarily derived from moist ocean air. Alberta clippers are drier with less snow and cold temperatures and occur east of the Canadian Rockies. Nor'easters occur on the east coast and can have hurricane force winds, heavy snows, intense precipitation, and high waves along the coast. The image is a weather map of a nor'easter. Notice the winds on the New England coast are coming from the northeast. Here is a map of the contiguous United States and Canada showing general winter storm tracks. These storm tracks are named for their place of origin east of the Rockies, with the exception of the nor'easter track, which is named for the direction of the wind, not the direction of the storm track when it hits New England. One of my personal favorite types of hazardous weather are ice storms. These are prolonged periods of freezing rain. Upon contact with cold objects, the rain immediately freezes to form a coating of ice, which can be very interesting to look at and very damaging too. Just look at the 3 images I show here. Power lines, dangerously sagging under the weight of ice. An ice-encapsulated VW bus. And crumpled power line towers. Interesting, and some of it expensive to fix. Ice storms develop during the winter on the north side of a stationary or warm front. There are 3 conditions for an ice storm to develop. 1. Ample source of moisture. 2. Warm air over shallow layer of cold air. And 3. Objects on land close to or at freezing. Here's the cartoon of our stationary or warm front. Frame A shows just ordinary snow falling from the clouds above. It is cold throughout the various altitudes. Precipitation exits clouds as snow and hits the ground as snow. Frame B shows warm air above a substantial wedge of below freezing air. In this scenario, precipitation exits clouds as snow, which is typical for most areas of the United States, even in the summer. The snow melts in the warm air, and then it falls through the large wedge of cold air near the surface. It freezes again before it hits the ground as sleet. Frame C shows our freezing rain / ice storm scenario. Snow from the exiting of the base of the cloud melts as it passes through warm air, then becomes super cooled as it passes through cool air, and immediately freezes on contact with surfaces that are below freezing on the ground. Frame D has above freezing air below the clouds, so the snow melts and just falls as rain. This series of scenarios is common in the Columbia River Valley, South Central Great Plains, Ohio River Valley, the East Coast, and the St. Lawrence River Valley. Where I grew up, in the Detroit, Michigan area, we would generally get ice storms about every other year. The ice was usually thick enough to ice skate on, but bumpy and wavy, and so you wouldn't actually want to go skating. One particularly damaging ice storm was quickly followed by strong winds, which caused a lot of broken tree limbs and power lines, meaning a lot of cleanup later. Another type of hazardous weather is fog, which we all know is a cloud in contact with the ground. It forms by air cooling to condensation or by adding water to cooled air through evaporation. So there are two types of fog. First, cooling fog. This occurs at night as heat radiates away from the land surface and the air cools, no longer able to hold the moisture it could during the warm day, resulting in condensation. This cooling fog also occurs as warm air blows over cold water, which cools the air and again is no longer able to hold the moisture it could when it was warm, resulting in condensation. This fog may then be blown back onto land with onshore winds, which is common in places like San Francisco. Another example of cooling fog is humid air rising up a mountainside. It was nice, moist, warm air in the valley, but as it rises up the mountain, the air cools, resulting in condensation. Examples of evaporation fog include cold air flowing over a warm body of water that has a lot of moisture to give away, but the cold air just can't hold it. So, condensation. Another example of evaporation fog is warm rain falls through cool, dry air. The image is a picture of fog and the driving hazard it can pose. Another type of hazardous weather is drought, which can be defined as an extended period of low or below average precipitation. It produces a shortage of water for people, animals, and plants, which can lead to regional food shortages. It can cause power shortages, especially in areas that rely on hydroelectric power. This natural hazards affect more people than any other natural hazard. The image depicts some drought conditions with limited water, agricultural problems, and a person that I'm guessing is stressed out by the problems that this drought may be bringing. Maps such as this one for October 2004 are created to show areas of drought. Maps are often created on a monthly and weekly basis for hazard management purposes. On this map, we have areas of drought marked in yellow through red colors, with red being exceptional drought. Letters indicate whether agriculture is impacted, A, or if there are hydrologic, i.e. water impacts, H, or agricultural and hydrological impacts are felt, AH. What uses do you think a drought index map would have for hazard preparedness? Another type of hazardous weather are mountain windstorms, and we will discuss them in a little bit.